So here we go. I'm gonna add some highlighters and stuff like that. You know me already by now. So I need you to always focus on the big polygon, not the dashed lines. See how there's some even that like go out of that shape? We're used to that too, by the way. We did that earlier. So if you don't mind, I mean, even if you just pay attention, I'm fine with that if you already did this. But I will always say focus on the big polygon first, right? Focus on big poly, right? Oh, I'm out of my frame there. Focus on big poly. Like, don't focus on the dashed lines just yet. Like, don't do it, right? Because you need to start. And I think there's some confusion, and I might have to change it. I'm gonna go back here. Maybe like I don't know if I want to do it, but some of you were confused. Like, there's A's here, and then there's A's in the other one. And you're like, I don't know what's happening here, Mr. Dirks. Like, I really don't know. If you want to replace this with capital I, right? Just say like this is really, these are all capital I's. Like the A represents capital I, the interior angle of that big polygon. That's what that represents. So that's why I added that here, nice and big so you would see it. So maybe don't fixate on A, fixate on the fact that it's the interior angle of the original big polygon, right? That's what that is. So let's go back to 46. And so that's my first order of business. Notice that none of these letters actually call for interior angle. Did you notice that? None of them call for the interior angle. Interior angle is just part of the process. So I'm going to go interior angle of this. How many sides? 15. I of 15 is just 15 minus 2 times 180 divided by n. And so that's 13 times 180 divided by 15. And that is 156, sorry, 156 degrees. Okay, this is capital I, and that's very important, right? It's very important in order to, that's why I gave you so much space here, because if you do it right, there it is. So now I'm going to focus on this triangle here. So maybe I will just go dashed like that and just exaggerate a little bit and say that this is A right here. That is the base of this triangle, right? Base angle right there. I know that this is 156. Right? I know that what I just found is this one, this chunk right here. Between the two sides, right, they create the big polygon, that's 156. So angle A is 180 degrees because a triangle has a sum of 180 minus the one interior angle. Make sure you don't forget to either hit equals or do brackets, right? Like use brackets. And so when you take the 156 away, you need to split what is remaining in half because we know that both of these are actually the same. So what is that? That is 24 divided by 2, which ends up being 12 degrees, right? So there you have A is 12 degrees. Like that actually, this in particular is 12, but we also know that that is 12. Okay, so much fun, eh? Next, I'm going to go to my trapezoid. Do I have to go trapezoid next? No, you don't. Right? So angle B, should I? I'm going to do it just because I can. Okay, so we have dun, dun. It's not a very nice trapezoid, but so that's 156. That's 156. Okay, and this is B here. Okay, so to find B, I'm going to say this is a quadrilateral, which a four-sided shape always has a sum of 360, always, minus 2 156 degrees, right? These two here. And I will do this. Divide that in 2. And some of you already know the answer. 360 minus, in my key, I just rush right to the final answer, which I shouldn't. So let's just do 12, 3. Did I do that right? Let me try this again. 2 times 6 is 12. Boom. 2 times 5 is 10. That's 11, sorry. There you go. That's better, right? Divided by 2. So that's 48 divided by 2, which is 24 degrees. So now you know angle B is 24. I'm going to pick a battle right now and just say, hey, I'm going to find E right away because I know these two add up to 156, correct? Right? These two angles add up to 156 because right this corner here you have a 156. So angle E is 156 minus angle B. So it's 156 minus 24. And so angle E is 132. Yeah, just making sure. That's supposed to be E, okay? So I've got that taken care of. So I did both of those at the same time. Now I'm gonna go to this one here. Maybe you should recognize that that's a pentagon, right? It's not a regular pentagon, but it is a pentagon. So I'm gonna try it here. Is C gonna work out? Pentagon, it needs 1, 2, 3, 4. 1, 2, 3, 4, and then the dashed line here. So this is C. So to find angle C, I'm going to go 540 minus 3 anterior angles up here. Right? So 156, 156, 156. So 3 times 156, all of that divided by 2. Make sure you put some sort of brackets in the numerator, and you get, apparently you get 72 over 2, and that's 36 degrees for angle C. This is angle C. I'm just going to make one more line here. There's 36. So much fun, eh? Now we're going to do D. Angle D is, let's go back up here, just making sure. C and D add up to 156 again, right? At every corner, things add up to 156. So angle D is 156 minus angle C. Angle D is 156 minus 36. And that's 120. Yeah, sorry. I was just making sure. My key is a little different, as you probably have noticed, right? It's cramped on my key. And so for this version of your booklet, I gave you a lot more room because, quite frankly, you need it. And am I missing one? I'm missing angle F, right? I'm missing this one, which is way outside here. Can I just, I'm going to try with highlighters to make my point here. This is 156 here. This is 156. And I wish I could zoom in. I wish I had an iPad right now and just zoom in. But this one here and this one here, they're both exterior angles. Exterior, exterior, right? And F is really when these two dashed lines collide right here. You do see a triangle, but these two, like the exterior angle here and the exterior angle there, will be the same. What is it exterior to? It's exterior to this 15-sided polygon. Okay. So where should I do f? I'm going to do f right here. Is 180 minus 2 exterior angles. And by that I mean the ones I just labeled. Okay. And so angle F is, what is an exterior angle in this case? E is 360 divided by 15. Right? That's how you find E, which is 24 degrees. So each one of these little ones is 24. So we're going to go 180 minus 2 times 24. Yeah, so that's 132 degrees. So we have everything now solved. And some of you were saying that I've added angles in my key that are not in the original and the one you have. I know. Sometimes I go off on a tangent just to add more. But here it is, guys. Voila. It's all done. Okay. So it all hinges on finding your interior angle. And then that interior angle shows up everywhere. So maybe allow me to just say, hey, this is the interior angle. It showed up here. It showed up again here. It showed up again with the pentagon, right? So those interior angles, once found, those are what you subtract in each case. Sometimes just one of them, sometimes two, sometimes three. And this could be extended to anything. Pentagon, it could be a hexagon, like created by a diagonal. I usually stop at pentagon, but it could be a bonus maybe, right? Where I want to see, could you expand this, right? Okay, that's it for this page. Hopefully it helped you have another go at it, but you got to make sure like page 45 is still not done probably, unless you did, right? So you want to give that a try. What's my time here? Okay. I'm going to go to, I will leave 47 for now, showing lines are parallel. I will leave that. Let's go to tessellations. So that's not going to be on the quiz, the part I just skipped, right? Obviously. Go ahead. This is page 49. And page 49, tessellations deal with tiling questions. Okay. Do you remember doing tessellations in younger grades? They might have COVID. Never mind. They probably skipped that part. It's not crucial. You'll be fine. To determine this, we need to find out the interior angles, and if those interior angles have a sum of exactly 360 degrees. Okay. So do the following tessellate. Note, you have to use at least one of each shape mentioned. So let's say you want to ask yourself, hey, can I use regular triangles? Can I use that shape to tile a floor? Could I use it? I'm not sure. Well, mathematically, you should be able to prove it. So this is what I'm going to tell you. The interior angle of a three-sided shape is 3 minus 2 times 180 divided by 3. A regular triangle is a what triangle? It's called an equilateral triangle. We already know what the interior angles should be. They should be 60 each, right? But this is just to prove the point. So this would be 1 times 180 divided by 3, which is just 60 degrees. So you found out the interior angle of a triangle. And this is how you mathematically check. Okay, you go 360 degrees divided by 60 is equal to 6 tiles. An exact number. An exact number. Therefore, you can tessellate. You can tile the floor. You can tile the floor. So how does that work, Mr. Dirksen? Well, look at this. Like you have a 60 here, a 60 there, 60, 60, 60, and another 60. So you have an exact 360 degree circle when you put these triangles together. Okay. So if you find the interior angle and you're able to say, hey, 360 divided by that interior angle is an exact number, then you can indeed tile a floor. What about regular pentagons? Will you be able to tile the floor? Look at the diagram. I already put them together. So we focus in on one point here, and we put the tiles, dun, 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 right? There's a little bit of a gap there. Do you think you can fit another pentagon in there? No. So pentagons are actually not going to work. But here's mathematically how you would show that. I of 5 is 5 minus 2 times 180 over 5. That's 3 times 180 over 5. That's 540 over 5. I ends up being 108 degrees. Now we check. 360 divided by 108. That'll give us 3 point something, right? 3.33. Not an exact number. Therefore, you cannot tile the floor. As easy as that. But that's if you're just using the same shape. What if you're using different shapes? And it'll be done after this, I promise. Then I'll give you that old quiz. You can try it. Could you use regular triangles? Squares, which is also regular. And hexagons. So can you use regular triangles, regular squares, regular hexagons to tile the floor? Another way of asking the exact same thing is, will these shapes tessellate? Can you like repeat that pattern and it will always work out? Let's try this. I give you full permission to triangles and squares to just give me the number. Interior angle of a triangle would be 60 degrees. Interior angle of a square would be 90 degrees. Interior angle of a hexagon, anybody remember? I don't remember that kind of stuff, Mr. Dirksen. I just used the formula. Well, okay, fine. That would be 720 divided by 6. So the interior angle of a hexagon is actually 120 degrees. So all the shapes that are in question, you just line up their interior angles like this. That's how I would suggest you answer this question. Here you cannot just divide because you have different shapes. So what you do is you start with 360, right? Start with 360 degrees and subtract each interior angle. Let me see if I can zoom in a little bit for you guys there. Start with 360 and then subtract each interior angle. So we go 360 and I will go minus 60 because I want to use a triangle, I want to use a square, and I want to use a hexagon for sure. So I will just say triangle, square, hexagon. So let's do some mental math here. 60 and 90 is 150, right? And so that'd be 270 already. So we're left with 90 degrees. So you've used one of each shape for sure. What other shape do you recognize? So sometimes you have to keep subtracting, but this is actually perfectly filled in with another square. Take another 90 away. So your goal is 0 degree left. Therefore, you can tessellate. Or tile the floor. I usually ask you to give me the combination, right? Use 2 squares, 1 triangle, 1 hexagon. So if you use that combination every single time, you will be able to tile the floor. And I think while you're doing the while you're starting the quiz, it's a mock quiz, so don't get all excited. I will show you. I have with my iPad. I can show you that actually is true. Like I'll keep copying this shape, and we'll just try to put it together, and you'll be able to tile an entire floor. Or if you do like a wall pattern, a backsplash, you could actually do that, and you just keep going. It will always work out beautifully, right? And so obviously the next one would not work out for you. Okay, I would like you to try just 49 and 50. Okay, so 49, just what's left over here. 49 to 50 on tiling, right? Tiling questions. Tiling questions.